Okay, welcome back to section 8.2, which deals with symbols, order of operations, which is known as PEMDAS, and also expressions. So some of this is going to be a review, which I understand. So we continue to make sure we're getting the concepts. That's why we're going to continue doing this. So 2 to the third power is not 6. What 2 to the third power is 2 times 2 times 2. Now notice, I multiply 2 by itself 3 times. So 2 to the third power is 8. Now what about 4 squared? 4 squared is the same as saying 4 times 4 equals, well, 4 times 4 is 16. Now these are review of what we've learned so far. Now I want you all to think about this for a second. Now at any point you can always stop this video and wait and do these examples and come back to it. Now what is 4 times 5 squared? Now here's what I've seen in the past. We take 4 times 5 squared and you get 400. This right here is a big no. What you have to do is you have to take 4 times 5 squared, because that exponent is attached to that 5. So 5 squared is 25. So 4 times 25 equals 100. And this gets to, you'll start seeing some problems where we're going to throw a lot of operations at you, and plus our new terminology, what we learned in our last section in 8.1, which is the absolute value symbol. So I'm not going to do anything with the 9, but I'm going to treat the absolute value as parentheses. What is 10 subtract 8? Well, it's a positive 2. Now if it was a negative 2, remember what comes out of the absolute value is the positive side of it. So it would still be plus 2. And then 4 squared is 16. And we put that over 7 minus 3, which is 4. Now what I'm going to do is I'm going to say 9 plus 2, which is an 11, plus 16 is 27 over 4. Now if it asks you to put it in a mixed number, 4 goes into 27 6 times, which gives us 3 remaining, and it's 4 is still our denominator. Now this is what we're going to start seeing as far as expressions and all this is concerned. So what this means is, let me erase this equal sign. An expression is just an 8x plus 4. But now when you put an equal sign and an answer that's to that, then that is when, so if I had say 8x plus 4 equals 20, for example. This right here is an equation. But what is 8x plus 4? Well, the only way we can tell what that is knowing what x is, and that means x is 2. So I'm going to say 8 times 2 plus 4, which comes out to be 8 times 2 is 16 plus 4, which is 20. Next I can ask us, okay, is 7 a solution of x plus 2 equals 2 plus x? Well, let's put our 7 in. 7 plus 2 equals 2 plus 7. That gives us 9 equals 9. And since both sides of the equal sign is 9, that is a true statement. Now, if one of these was not a 9, maybe it was like a 10 or a 12 or something, or even a negative 9, they both have to be the same to be a solution. If they're anywhere different, it's not a solution. Now the m over n plus 2p is an expression. So what I need to do is this. I need to substitute my values in. Well, I know m is 16, n is 4, plus 2 times p, which is 3. Now 16 over 4 is 4. 2 times 3 is 6. So my answer is 10. And finally, is x equal 3 a solution of 2x plus 7 equals 12? Well, what I want to do is this. I'm going to kind of color code this a little bit better. So my parentheses is what my x is. So I'm going to say that is 3. Now let's fill this in. What's 2 times 3? It's 6 plus 7 equals 12. 6 plus 7 is 13. Now, even though that is close, that is what this symbol means. 13 is not equal to 12. So is it a solution? No. Okay, thank you for listening. Be looking for my next section of 8.3, which is adding real numbers. Thank you very much.